yeah, just being aware of these things, the fact that it's an absolute jungle out there, and people will come out for your money. And because of the whole sort of decentralized and open nature of this network, you end up having so many more adversaries than any other traditional IT system, if that makes sense.
That is Mehdi Zerouali, and this is episode 36 of the Blockchain Pro podcast. Hello and welcome to episode 36 of the Blockchain Pro podcast. I'm Adriana, and today's guest is Mehdi Zerouali. Mehdi is one of the co-founders of Sigma Prime in Sydney. He's been in the cybersecurity industry for over a decade and currently focused on helping projects secure their decentralized protocols. We will talk a little bit about that as we discuss his career and what he's working on.
Hi, Mehdi.
But we will also
Adriana.
talk about
How
what
you
you and I
doing?
Good,
can
thanks.
do
How are you?
to
I'm
keep
right.
our
Thanks
reserves
for being
safe.
here.
Of course. My
Let's
pleasure.
get to
Thanks
know
for having
Mehdi.
me.
My pleasure. Let's go back in time
Yeah, sure.
and let's find out how you got started with crypto security.
Yeah, so I've been in the cybersecurity space for about a decade now. So I started my career finding bugs in people's software, working for a Big Four consultancy, previously in Paris and then more recently in Sydney. And in Sydney, I kind of met the people that introduced me to the blockchain space. I actually had heard of Bitcoin before in 2011, tried to understand it as I guess a lot of nerds back then, but it never really kind of blew up my mind. I was struggling to understand the value proposition. And then, one of my friends took the time to explain to me Ethereum. And I remember that conversation very well. And I walked out of it completely transformed and kind of realizing that this was something I really wanted to be involved in. Long story short, that group of friends started doing things around the blockchain space in Sydney. So particularly attending the Sydney Ethereum meetup, providing ad hoc consulting and advice to various projects and various people in the space. And to a certain extent, we kind of decided to structure a bit more this offering of ours. And I was actually the last person of the four original co-founders to quit their jobs and kind of fully join Sigma Prime full time. And that's how Sigma Prime got started.
So what were you doing? Which job did you quit?
So I was back then. I was a manager of a penetration testing team. In a Big Four consultancy, EY or Ernst & Young. So basically, my job was essentially finding vulnerabilities or helping my team find vulnerabilities on websites, mobile apps, AWS infrastructure, cloud infrastructure, etc. Primarily for financial services, but also servicing a whole heap of different sectors and industries. Been doing that for 6 years, 3 years in Paris, 3 years in Sydney. My job now is very, very similar. I still find bugs, but we only operate in the blockchain space, as you know.
So for people who are not very familiar with cybersecurity as a whole, penetration testing is one of the areas.
Correct, absolutely.
What are the other areas?
There's plenty of other areas in cybersecurity. You mentioned penetration testing, pen testing. It's essentially this technique that allows people to identify vulnerabilities on systems. But obviously the cyberspace is much broader than that. People are looking into what we call IAM, so identity and access management, making sure that people in an organization have access to what they need to access and no more. It's quite important. Then you've got a whole sort of discipline around incident response. So when people unfortunately get hacked, what do? They usually come to those people, incident responders, that they try to mitigate the breach and understand and assess how bad things got. So that's one. And then I think perhaps more recently, or over the last 10, 15 years, we've seen a lot of cybersecurity pushed in consultancies around organizational cybersecurity. So things like establishing processes in large organizations to drive the change to essentially have a better cybersecurity posture. So this particular job, for example, is not necessarily super technical. Doesn't require you to be a developer to actually have an impact on the security posture of those organizations.
Is that more to do with like training employees so they know how to?
Yeah, so there's certainly a massive security awareness training component to these activities. There's also a lot of interviews and conversations with heads of departments to understand where their critical assets live, how often do they look after them in terms of security, is there any sort of patch management system in place, etc. So it's really trying to get your head around the entire organization and understanding their assets and obviously the threats that could potentially harm them.
That is, I find that a very interesting area of business.
Me too.
Okay, so let's talk blockchain and cyber. So
Sure.
what was in Ethereum that attracted you, and so what does securing Ethereum mean?
Yeah, it's a great question. So for our listeners that don't necessarily know Ethereum that well, it's perhaps worth explaining it very briefly. Ethereum was the very first blockchain that introduced the concept of smart contracts. So smart contracts are basically a little piece of code that can run autonomously, in an independent fashion and in a decentralized manner on the Ethereum blockchain. So you can think of them as pieces of code that can basically do whatever the developer wants them to do. So you have what we call Turing completeness, or the ability to essentially write up any business logic that you can think of. Now, back then, this was in 2016, 2017, most of the projects that would build on Ethereum, would build these smart contracts, would essentially be what we used to call ICOs, or still call ICOs, initial coin offerings. So for people who have been around for long enough, they probably remember these sort of money grab projects that were asking the community to send them cryptocurrencies, Ether in this case, in exchange for tokens. And those tokens would then be tradable on a secondary market. And I guess a lot of people in the community back then were trying to sort of flip those tokens. So kind of get in first, get a nice share of the tokens with the intention of selling them obviously higher for what they bought them at. So that was a lot of the activity around Ethereum back then. So I think what really interested me the most when it came to security and Ethereum was really trying to understand how bad those smart contracts could be coded. In fact, a lot of your listeners remember the DAO event. So the DAO was one of the very first experiments on Ethereum, which attracted a lot of money. I believe, if I recall correctly, it was around 150 million US dollars back then. It's probably close to multiple $1 billion now of Ether. And a hacker found a way to actually drain that smart contract of that Ether. I think everyone who was in that space remembers really well where they were that night. It was nighttime for us here in Australia. And I remember being kind of mind blown by the impact of this hack on the overall sort of ecosystem, and really trying to understand the intricacies of those smart contracts. They use, as we said, Ethereum. They're built using a programming language that was created for this purpose called Solidity. Kind of looks like JavaScript, but it's definitely not JavaScript. And the actual architecture on top of which this runs is called the Ethereum virtual machine. So after that, I really got into the Ethereum virtual machine, really trying to understand it a bit better, understand its limitations, stuff that could easily be broken by adversaries, and obviously trying to come up with solutions for developers to be able to secure those applications and even better code them in a secure way in the first place.
So it's like they put all this money in a box, and instead of locking it with a lock pad, they put a bow on it.
Yeah, pretty much, exactly. Back then it was, we didn't really understand those attack vectors quite well, to be quite frank. And Adrian, my co-founder, spent a lot of time actually documenting all the attack vectors that were known to the community back then. And he's done an amazing job at it. That blog post is on our blog and has been basically used by Andreas Antonopoulos and Gavin Wood in their Mastering Ethereum book. So the smart contract security section of the book is what Adrian wrote. So it was a very interesting, I guess, research phase for us, really getting our head around those intricacies and how we could potentially see ourselves improve the ecosystem by providing either some tooling or training, or what we end up doing, assessment services on those smart contracts.
Interesting that you mentioned Andreas, because I remember back in the day Andreas talking about smart contracts in the Bitcoin blockchain. Have you explored those? What are the differences?
So I believe, I'm not a Bitcoin expert, perhaps should preface that. You do have a way of kind of coding business logic in Bitcoin, which is by using what we call pay-to-script, P2SH.
Mm-hmm.
But I remember back then looking into it, and the kind of learning curve there was really, really stiff. And when you looked at Ethereum and Solidity and compared that to P2SH in Bitcoin, it was kind of a no-brainer,
Okay.
right? Things looked very simple, or at least much more simple on Ethereum than on Bitcoin. And I believe it's probably still the case. I know some projects are still trying to bring smart contracts to Ethereum. Rootstock is probably one of them. But I'm certainly not across the details and technicalities of that space.
Oh, that's fine. I just wanted to, put it out there that there is a way of doing smart contracts. And Bitcoin is they probably don't have the same capabilities, because Ethereum was built for smart contracts, right?
Absolutely.
All right. So what are some of the misconceptions of blockchain securities?
That's a very good question. I think what I find the most, at least the most concerning, when I speak to friends and family who are kind of getting into this space, my girlfriend Lucy is kind of asking me about this stuff all the time. And what a misconception that I find quite widespread is the fact that if it's on a blockchain, it is decentralized and it is trustless. Well, not really, right? Mm-hmm. You can deploy a smart contract on Ethereum and kind of have it behave completely differently for a specific user, right? So you could actually go ahead and code your smart contract and say, if this user is interacting with my smart contract, then that user will have, God privileges on that system. So again, it's not like deploying these things on a decentralized network does not make them decentralized in nature. And I know this is not directly answering your question, but I think it's quite important, because a lot of the, security incidents that happened over the last few years were actually related to this centralized aspect of those smart contracts. So really, when you're looking into interacting with those systems, ask yourself the first question: is there anyone that could turn this off or potentially drain the value that it holds? It's often a question that's quite hard to answer. You'll see, especially in the latest systems, those special privileges are sometimes hidden under layers and layers and layers of access control. But it's our job and a lot of other experts' job around the world to point out those potential violation of trust assumptions.
So do you think people put those, let's say, buttons in because they just want a way of avoiding risk, and then they're creating risk? For example, in the DAO, when that happened, Ethereum had to fork to override what happened, and by fork we mean the chain that was where the hack was turned into a new chain where the hack didn't happen, and the new Ethereum was created, right?
Absolutely.
So do you think people would put this push button in their contract just so they could take their 100%. Money back? Okay.
A lot of our clients are using this as a mechanism to pause the contract if anything bad would happen.
But then you have to secure that really,
exactly,
really well.
Exactly. What happens if that particular account that composes the contract, well, what happens if those keys get leaked, for example?
Or if the person who has access goes crazy
exactly,
and wants to steal it.
So there's ways around this. One of our recommendations is to kind of use a multi-sig contract, right, which essentially would require a number of people to authorize a certain action. That gives a little bit more confidence to the end user, but it is at the end of the day a trade-off between the ability to respond quickly to incidents and the decentralization nature of those systems. If you want to be able to pause your system, well, it's probably not going to be that decentralized. And vice versa, if you really don't want to have any control as a developer over your system, what happens if things go wrong? Usually, well, nothing. Things go wrong, things are wrong, and people potentially lose their assets, and we all move on. So it's a trade-off, and what we've been seeing over the last few months, years, is projects kind of juggling between these two and trying to find the right middle ground to kind of cover both aspects. Very, very interesting.
Are there any other big misconceptions that you can think of?
Yeah, so in Solidity, without getting into too much technical detail, but people need to understand that blockchains, or at least Ethereum, is a public blockchain, right? When you code smart contracts, you can declare some variables to be private, and we've seen people actually genuinely think that by declaring those variables private, they think that no one will be able to actually access them, which is completely wrong. That variable, be it public or private, is stored on chain. As a public blockchain, everyone has the ability to go and inspect the state of that blockchain and therefore retrieve the content of that variable. So this misconception is quite common, thinking that, well, I'm just going to do my little thing in my smart contract and I'm going to declare it as private and it'll be fine because it's private. Well, not really. Not at all, actually. It's everything you do on Ethereum is public in nature. And there's obviously ways around sort of adding privacy to those solutions. I'm sure your listeners have heard of things like zero knowledge proofs that will be hopefully coming in, I guess, the base layer protocol soon, already used by decentralized applications, by smart contracts in production, that could bring another layer of privacy for Ethereum users. But assume that everything you do is recorded, everything you interact with is public, every variable you touch, store, read, write happens in the open. And I think that's a bit of a misconception. When last time I spoke with a blockchain developer around that, we're getting much better. By we, I mean the whole ecosystem. These things were fairly new a few years ago. Now you do get experienced Solidity developers that understand these things really well.
Yeah, these things are actually really being invented as they happen, right?
Absolutely.
None of this existed 5 years ago.
No, it's crazy when you think about it. I think that was the reason why a lot of us kind of moved into this space, because it was the opportunity to kind of be part of this massive change and being able to
Must feel really good.
help drive some of those conversations. Yeah, it does feel good. A lot of responsibility as well, as you can imagine, when you're auditing a smart contract that turns out to hold billions of dollars of value. We've just completed recently an audit of Aave, the main lending protocol on Ethereum, which currently holds about $3 or $4 billion worth of assets. So yeah, it is rewarding, but it's also extremely stressful in some times. Yeah.
So you have to feel responsible for that much value
Absolutely.
out in the open.
Absolutely. It's a challenge because compared to other traditional IT systems, where the attack surface is usually fairly limited, especially if you're talking about an application, a very critical application for a bank, let's say, that's kind of hosted in-house, right? It's not accessible on the internet. Attacking this from an external perspective would be, I wouldn't say impossible, but very hard, right? You'd have to first get your first entry point on the network and then potentially compromise other boxes on the network to get your hand on that particular server. On Ethereum, though, smart contracts are all public. Everyone and anyone can go and interact with them. It's just a matter of signing and sending a transaction. So it does attract, I believe, a lot more eyes, and the prizes are also very, very attractive. The DAO hacker, went away with millions of ETC now, because as you mentioned, we decided, the community decided to fork the chain, and yeah, so lots of challenges, lots of very interesting challenges, and yeah, the attack surface on this system is just massive.
So we've been talking about securing companies. How can users secure their tokens or their Ether?
That's a great question.
Oh, their Bitcoin, because I think the
cryptocurrencies in general.
in general.
I think this applies to all of them. It's a great question, and you know what? We've seen very savvy users get hacked lately. So when you see a founder of a quite successful project being hacked out of, I think, $5 or $6 million of his own tokens, his tokens in his own project, you kind of have to stop and think, are we doing things the right way? It's, as you said, this is very new. Everything is kind of being worked out and discovered as we speak, but I do believe there are some principles that users could and should follow to make sure that they're as secure as we can be. The first one, I'd say, if it looks too good to be true, it's probably fake, right? This is I think quite important, and I'm probably referring to some of the giveaway scams that were all over Twitter, mostly last year, I'd say. It was not too bad this year, but if someone promises you to double your tokens but needs you first to send him or her some Ether or Bitcoin, you are probably going to fall for a scam, right? Again, if it's too good to be true, it's probably fake. So just kind of using common sense and not, what people call aping into like this latest sort of smart contract that promises incredible returns. Be careful. You do some due diligence, right? Before investing or throwing your Ether or Bitcoin or cryptocurrencies right, left, and center, I would strongly recommend spending some time understanding the project that you're about to interact with, right? This includes, looking up who the team members are, understanding a bit more the protocol. It doesn't have to be super technical, right? You just need to be kind of comfortable with the people that are running this show and also the potential security measures that they have in place. One thing to look out for is the existence of security audits. Right now, we've seen a lot of projects get hacked even after having a security review, right? So I'm not saying that if a project has been audited, it's 100% safe, you can go for it. My point is, if a project has been audited by, reputable auditing firms, this shows me that they are taking security somewhat seriously, right? Then obviously these assessments, these audits are always time boxed. We have people come to us and ask for a few days worth of our time to review a system that would realistically take us weeks to actually audit. So, in some cases, it's just a matter of saying, no, like this is completely unrealistic, this is not going to work. But in some cases, the gap is not as big, right? And at the end of the day, we spend the time that our clients pay us to spend. So the more time you give us, the more chances we have of finding bugs. So really trying to understand a bit better what's their security strategy in terms of auditing, in terms of making sure that they have a bug bounty program so that if hackers were to find anything wrong with those contracts, they'd have a fair and easy sort of process to follow to report these and potentially get compensated. Those are, I think, the main things to look out for. Really, the existence of security audits, looking up the team, is there a bug bounty program? That, I think, would probably halve the number of projects that people interact with these days. There's also other tips, particularly around handling your own keys. So I think for the average user, relying on a cold wallet, on a hardware wallet, is a good idea. So there's a couple that are around, Trezor, Ledger. Ledger's had some bad press recently due to some, a leak in their customer database. But I've heard then people say, well, I'm not going to use a Ledger anymore. They got hacked. Hang on a sec.
Ledger wasn't hacked.
Yeah, the actual device was not hacked. The actual device is still safe to use. If you've unfortunately ordered your Ledger over the last 18 months via their portal, your details are probably out there, but it doesn't change the security posture of that device you purchased. So yes, strongly recommend using a hardware wallet. They're very affordable these days, and I think they can at least prevent some of the very, very basic type scams and hacks. But it's unfortunately not sufficient. The example I started with, that person had a hardware wallet and was using a hardware wallet when the hack occurred. And what happened was that they didn't check the address on the ledger that they were about to interact with. Having done this multiple times, they were comfortable with the process that they were following and just accepted the signature on their ledger and effectively signed a malicious transaction that sent out their own ballots, again, in their own project, out to a hacker. So terrible story. But again, this could have been prevented by simply checking on your ledger that the address you're interacting with, from the ledger's point of view, is the same as the one that you're willing to interact with on your computer screen, right? So always confirm the addresses you're interacting with. It turned out after investigation that this person had her MacBook hacked, and the hack was actually quite clever because it installed a bogus or malicious version of MetaMask. And what that malicious version of MetaMask did was simply replace addresses seamlessly as the user was interacting with the contract. So in this case, the only way to actually find out was by checking the ledger, the address on the ledger. So do that. Do yourself a favor. Every time you use your hardware wallet, triple check that the address you're about to interact with is indeed the one that you wanted to interact with in the first place. It seems kind of trivial, right? But trust me, it might end up saving you a lot of money. And this person, that's the only thing that they forgot to do. They're quite savvy. Like, again, they're a founder in this space. They've manipulated private keys for God knows how long, yet they fell to this scam. So just being aware of these things, the fact that it's an absolute jungle out there and people will come out for your money. And because of the whole sort of decentralized and open nature of this network, you end up having so many more adversaries than any other traditional IT system, if that makes sense.
Yes, it's very wild. It's like walking around with millions of dollars in your pocket.
Yeah.
Or thousands,
yeah.
If you're starting out.
Yeah.
It's very challenging to overcome.
100%. Another perhaps recommendation would be, if you're like some of my friends, quite careful with your privacy and the sort of traces you leave behind, maybe try to use different addresses. Make sure you have different addresses for each use case. So, I don't know, you're interacting with a smart contract, you're about to lend some money on a smart contract, might be a good idea to do that from a different clean address, just to make those, I guess, log recollection and log analysis processes that are being used by a lot of people bit harder. And just common sense, I think, is really the first one. Common sense. If it looks too good to be true, it's probably fake.
And yes, that is a very important one. And also understand how the key management work is another one.
Yes.
So
yes.
I think those are the two best.
100%. Backups are very important.
But you back up your keys.
Back up your keys, but you also need to understand that anyone with access to the backup would do as much harm as someone with access to your actual hot wallet. So my point is, when you decide to back up your private keys, please treat that backup the same way you treat your actual key. So there's, if we're talking about hardware wallets, Trezor and Ledger, mnemonic phrase, right? That is really, really critical, right? It's important to have a backup, but it's probably more important for that backup to be safe and secure against unauthorized access. Various ways of doing that. You could, for example, split up the phrase into 3 or 4 different chunks and give each chunk to a trusted family member. Mm-hmm. That's one way to do it. Another way is to kind of use, I know people who just deposit them at banks, in bank safes. It's just the safe just contains 12 words in a piece of paper. There's a lot of ways around that, but it is quite critical that those backups are secured.
You can hide them in your house, different locations.
Yeah. What happens if your house burns down?
Yeah, that's a good idea.
Yeah.
You could memorize it.
You could memorize it, but I wouldn't trust my memory.
Mm-hmm.
I know I've got terrible memory, but I wouldn't rely on that exclusively. Mm-hmm. And yeah, backing up in the same physical location as the original sort of asset.
What if one of the places you lock it up in your house is a fireproof safe?
Yeah, that's great. That's great.
Okay.
That's great. There's also a lot of conversations around, well, should I even have access to those keys in the first place if I'm storing a lot of money? People usually refer to physical attacks, especially around the leak that we've seen with Ledger. A lot of people are freaking out because their addresses, first name, last name, and mobile numbers are out there.
Oh yeah, if you're buying some sort of wallet, hardware wallet online, send it to your work address. Send it to
a PO box.
PO box,
yes.
Exactly. Even get a PO box just for that, and get rid of the PO box after.
And if you're wondering why, again, this happened with Ledger. We have, unfortunately, in the wild, the details of every single customer of the Ledger online shop over the last, I think, 18 months. So, yeah.
And we have to learn from these mistakes,
yes,
right?
Absolutely. Another way to do it is to kind of just buy it from a retailer. Like there's a few distributors, I'm sure, wherever you are.
Yeah, but make sure when you do that, because I remember there was a problem with one of these wallets before, where they were buying from some online shop, and the ledger will come with the mnemonic phrase that was the people who were selling already knew. So as soon as money hit the wallet, they would just take it all out.
Absolutely, that's a very good point. Make sure that before opening your new device, it is sealed. It has to be sealed with the company's sort of logo and seal. So that's critical. A hardware wallet is worth nothing. It's actually a liability if it's been used before, right? If it's been tampered with.
Don't buy it secondhand.
Don't buy secondhand hardware wallets. Terrible idea. Just buy them from official sources and make sure you set them up properly and make sure you secure that backup properly.
And I would even say don't just have one.
Yeah.
Have more than one. If you have lots of tokens to store, have more than one, split them up.
Split them up. Totally. Redundancy here is certainly a good idea.
Awesome. All right. So what can people do to contribute to this space?
Wow, there's a lot to be done.
Your team has been contributing to this space for a while now.
We've been trying our best. So working quite closely on Ethereum, as you know, working closely with the Ethereum Foundation. We have implemented an Ethereum 2.0 client called Lighthouse. It's written in Rust. So for those of you who don't know, Ethereum is transitioning to a proof of stake consensus mechanism, and the first sort of step towards this massive change was reached on December 1st with the launch of the Beacon chain. So think of it as a completely separate chain that kind of runs in parallel with the current Ethereum chain, and the bridge between the two being a deposit contract on the Ethereum 1 chain. If you want to become a validator on the proof of stake chain, on the Beacon chain, we don't call them miners anymore, we call them validators, you need to deposit 32 Ether on the Ethereum 1 smart contract, deposit smart contract. And this is how you kind of transition and migrate this Ether over to the Beacon chain and become a validator. So our team has been really, really busy with implementing this over the last 2.5 years. The first I guess, commit on that repository was in July 2018.
Wow.
Yeah, it's been a journey. It's been great. We're one of the 4 teams around the world with a production-ready client. So there's 4 clients. Lighthouse is one of them, and there's so much to do. So if you're interested in helping out on the Ethereum 2.0 research and development space, please reach out to us. Particularly if you're familiar with Rust, we are seeking Rust engineers to essentially, help us make this new Ethereum platform a reality. This year should be the year of the merge. So merging Ethereum 1 and Ethereum 2. Very exciting and extremely difficult task ahead. There's a lot of other ways people can contribute. I get this question a lot from non-technical people. So developers usually kind of know that they could just reach out on GitHub, flag the repository that they kind of want to contribute to, and
they
just
can scan
kinda,
projects for bugs and
report
receive the bounty.
Exactly. For non-technical people, it's maybe sometimes a bit less obvious what they can do. But trust me, there's so much that can be done. One area that I can think of is documentation, user documentation. So if you've spent a lot of time understanding how a system works, understanding how, for example, in our case, you would run Lighthouse as a validator, and you notice gaps in the resources that you use to actually build up your knowledge. Well, one way to do it is to just kind of write a few notes and keep that information to yourself, and perhaps if you have friends that are involved in this, share that with those friends. But perhaps a better way of approaching this would be to reach out to the developers and say, hey, I'm actually going through your entire process, and I think you're missing X, you're missing Y, and potentially missing Z. I don't know a single developer who would not welcome this feedback, and it's certainly super valuable, because it would then help a lot of people after you not spend the time that you spent kind of putting those pieces together and bridging that gap, that potential missing information. Documentation is really, really important. I think as a community, we can do a lot better on that front, and we need people that aren't necessarily developers to really help with that. You mentioned security. If you see something that you think should not be there, please speak up, but please do so responsibly.
We need a report a scam helpline.
Yeah. Oh, that helpline would be so busy. But yeah, you probably don't want to discuss those security bugs in the open.
Yes.
So for us, for example, you can reach out to us privately using our PGP key. Just sign your message, send us an email. Details are on the repo, and definitely get back to you very quickly. We take security very seriously. So yeah, if you find bugs, report them through the right channels, write documentation, ask questions on Discord, support your core developers, be it through donations or even just by congratulating them if you are using their product and you think it's a great product. It goes a long way. Just being nice to the developers that actually helped build that software. I know we use Discord to interact with our users, and the amount of support and thank you messages that we received after the launch was really, really, really heartwarming. And I know a lot of our team, of our staff, were very, very grateful for those messages.
After months of not sleeping very much.
Yeah, it was quite stressful, but hey, got there in the end. We're now secures about, I think, $6-7 billion Aussie worth of Ether. So and climbing. So yeah.
That's very exciting. All right, I think we overtime. Awesome. I love when that happens. That means it was a great convo. Thank you so much, Mehdi, for being here today.
No
Say
worries.
hi to the guys at the office.
Will do. Thank you, Adriana. Thanks for having me. And stay tuned.
Awesome.
And that was the always smiley Mehdi Zerouali. How good were those tips? Let's recap, shall we? Number 1, if it's too good to be true, it's probably true. And I think we've talked about this in the last episode as well. Triple check the addresses when you're sending money from one to another, because sometimes that's a vector attack, and if your computer has been compromised, the address can be changed, so make sure the destination address is the correct one before you click send. If you are doing things with smart contracts, make sure to use different addresses for different purposes. Backup, and backup. Make sure your keys are safe, either divided amongst trusted friends, in a safe deposit box, in a fireproof safe, all of the above. Make sure to look after your keys. Buy only sealed hardware wallets. If you can, more than one is always a good idea. And use a work address or a PO box to send them to yourself. And that is it. If you'd like to get in touch with Mehdi, I will add links to Sigma Prime website, their GitHub depot, and socials in the description. To get in touch with me, you know what to do. Hit me up on LinkedIn, on Twitter, send me a message via blockchainpropodcast.com. And if you're feeling generous, stop what you're doing right now and write a review. That really helps with algorithms everywhere. If you're listening on YouTube, give it a like, subscribe, click the bell button, do all those good things that, help channels grow. I will certainly appreciate and be eternally grateful. That's it for today. I hope you enjoyed this few minutes with us. And thank you for joining me in this journey of discovery. I will see you on the next block. Bye.